Hey guys, and welcome back. So now we're going to continue and start implementing the fracture, the uprise fracture on our actual geometry. And before I do that, I want to show the sim. I did run it, I let it run for 180 frames and I didn't cache the sim, and this is how it looks like. There's tons of details everywhere. We have 60,000 pieces and it was quite fast to sim. As you can see, there's no weird issue with any of the pieces. Everything is working as expected. You can see this piece didn't activate as much and it's still inheriting its motion. The issue that I talked about, where if we erode or start activating a lot of pieces, we will get weird issues. This would be an example. If we, for example, activated pieces here and this whole block is using that to rotate on, it's not going to look realistic. It's still going to move and all, but we may see some pieces that are floating and it's not going to make a lot of sense. Another example is if we erode out or activate the entire piece, the entire geometry of certain blocks. Look at this guy here. You see over time it's going to be activated, pretty much all of it. And so we just lost the core of that geometry, which could lead to very, very interesting effects. If we want to create some really complex dissolve of some very high-res building or something like that, we could go with this technique definitely and use a layering approach. But in this example, I think it would make sense to keep some of the core tight and not activate everything. You can see it here as well. You can see the erosion on this guy. It's going to continue activating and it's rippling through. Cool. So let's fracture our geometry, and I'm not going to use everything live. I'm going to use the main front or a block of it, so it's fast to work with, and then we're going to and then I'm gonna run it on the entire sim. And the geometry that I was talking about to swap, or planning to swap with a high-res one, is this guy here. This back wall is what I'm planning to swap with a high-res geometry that is completely different. So let's remove that, because we don't need to upres it using this method. At name is equal back wall. And it's let's see, it's a primitive attribute, and let's put a star here, not quotes. Yep, and that deleted the wall. And then we don't want to uppres everything. We only want to uppres the big blocks. Okay, if the geometry or the piece is too small, then we don't want to do anything to it. We just want to keep it. So let's use our compute mass node. No, we didn't create a node for that. So I'm going to copy it from we had it here. I'm going to copy this and let's use this color node. And this is our setup, by the way. This is a scene file from the previous week, and I'm gonna name it as week 5. That's for fracture start. Okay, let's measure size. Let's take a, okay, and I'm simply going to remove any small pieces. The bricks, for example, is definitely something I'm not planning on uprising. We could, but it's not. Bricks don't fracture too much. We could probably pick the region where Kong is gonna go through and fracture that separately, but other than that, I'm not planning on fracturing that. So actually the red pieces are what we're not going to fracture, which looks like a lot, to be honest, but that's fine. Okay, so let's copy this. set it to black, set this to white, and let's remove everything that is black. I shouldn't have checked this. Okay. I want to make sure that the geometry, I don't want to delete half of certain pieces or anything like that. Just want to make sure that I include all the faces. So this is what to upres, and this is to keep. So delete non-selected, that's what we're going to leave intact. And this is up to you guys, but all these small pieces I'm not planning on touching. Okay. And like we did before with the name attribute, I want to first make sure that I keep a copy of this, of that guy. So let's create a wrangle node. And I'm gonna call this main name, and it's equal to the name attribute, and it's a primitive attribute. Cool. And let's delete any attribute we don't care about. Let's delete this wall, the color attribute. Okay. And actually I only need the name attribute for now. If we need something else, we will bring it back. So main name. And let's see. Yeah, that's all I need at the moment. And then we're going to do a for each named primitives. And we're going to loop over each one of these guys. And again, we removed the name attribute. Probably let's leave it so we can do the loop over, and that's it. Okay, so instead of operating on everything, I'm going to select a couple of pieces, something, maybe this entire block. And I'm gonna blast that. It's gonna leave some interior faces and stuff like that, which is fine. I'm gonna fix it using an assemble node, and I'll show what I mean in a second. So I'm gonna pack these guys, and this way it will only select the entire pieces based on their name. I could have done this using a simpler method, or a select by name or by attribute, but this is gonna be fine for now. Okay, and let's remove that, and let's unpack this, and we're back to where we were. And again, this is just to make things faster. And let's start. I'm not interested in that piece. I'm gonna set the single pass, and I'm gonna scrub through until I hit an interesting block. Yep, it's this guy. This guy I like. So we want to fracture this. And the first thing is I'm gonna fuse the geometry. Or I'm gonna tell you the issues that we're going to run into, and how I'm gonna fix them right away because I know this from experience. We're gonna run into issues to subdivide this, to divide things like this. You see, we have a very end-gone face, and it's just not gonna work with the Voronoi. You're gonna see a lot of issues. So I'm gonna fuse everything. I'm also going to divide it to divide the geometry, so we don't have any n-gons or anything like that. And then we fuse the geometry, and that's what we're going to fracture. We're going to lose something called the inside faces for the original geometry, but it doesn't matter too much with this method. And I don't want to do it on actually it's fine, I'm gonna keep it there. I'm gonna isolate the outside faces here and the inside as well, so this guy. And I don't need to do the divide, I don't need to do the divide on everything. I'm only going to do it on the outside, on the inside faces. Let's set it here, inside. Delete non-selected. I want to see the name. And then this guy is going to be the outside. Call it outside. And I'm not going to touch this. So this is our interior faces. And then I'm going to merge all of this. And this is going to be the geo that we're going to fracture. Okay. And we don't want to fracture it just like that. We want to fracture it so that we have enough details or a lot of pieces on the edges and fewer at the center. So using the inside faces, I'm gonna scatter points on top of that. Okay, I'm gonna set it to 100 for now. Don't need any relaxation feature. And let's use a Voronoi fracture node and fracture it. And you can see already we have some issues here, but this is the best we can get at the moment. Let's put a fuse node. If we decided to fuse everything, which will help, but again we will lose the interior faces, it will help with this. It will help with this issue basically, because right now the geometry is open. This guy is separate from this guy. And if we fuse everything, it's gonna be better. Also, the Voronoi from Houdini 16.5 is much more stable, and I have a copy from 16.5. There's a way to use the open hide as well. Not that, this. But you can see with the Voronoi old, we didn't have to do the fuse, okay? It worked right away just with the divide, and our geometry is still open. I personally still prefer this, and I've used it in the main sim and the main setup or the promo video. This is what I used. And this guy, we have to fuse the geometry to get it to work properly. We will see some other issues because of this, but pretty much we always have to provide it a watertight mesh. Now let's visualize this. You see we have a lot of details here, but the pieces are quite elongated, so I don't want that. And the way to fix that is we need to add more points to the center. So right now we only have points at the edges, and we need to add points at the center. So I'm gonna convert this into a VDB, and let's use something like that. I want to use something high to capture that will work with all the pieces, even the small geometry. And I'm going to scatter some points inside. Scatter, and I only need 10 points. And let's merge. And you can see now we have a few pieces at the center, and then the edges have a lot more details on them. So let's loop over and see what we get. I'm gonna turn off the viz, and let's loop over all the pieces and see what we get. Okay, it's still going. With the a compiled block obviously is going to be much faster. Okay, it is done, and let's use color node. Let's create a new assemble, a new upres, and let's see. Cool. So this is our fracture. And let's pack it. Actually, this tells us no. Yeah, so we have 8,500 pretty much pieces, and then here we have 120 pieces. So that's that's the amount of details we're adding to the geometry, and we can keep increasing the resolution as much as we need to. Now, I'm not very happy with this, and I want to show you guys a couple more tricks that we could do to improve this fracture. We could obviously use this, but I want to create something where, let's turn this off. I want to create something where I can know which pieces are at the edges and which pieces are at the center, and basically I want to have like a depth map inside this geometry. And also I want to use another method. Right now this method works great if you have a flat geometry, but if we have something like those small pillars, we're not going to be able to scatter points nicely. And in that case I want to use a different method which relies on a surface field, and then we're going to use VDB from sphere, or what's the name of the node? VDB to sphere. So what this is going to do is going to pack the entire geometry like we did with Kong with spheres. And this is great because it will give us enough points to fill the geometry, and then fewer points at the edges. And this is going to be a great way for us to subdivide the core, or keep the core of the geometry. So let's try a few things. In radius, let's try 2. Something like that. And then what we can do is we can use an add node, delete geometry but key points, and that will give us very nicely distributed points on the geometry. So I'm going to use that instead of the scatter. And let's visualize the pieces. You can see we have not the same fracture, but we have nicely distributed Voronoi pattern onto the geometry, and we can lower this if we wanted to. Sorry, we can increase this. Now the other thing I want to do is I want to create this kind of gradient or a depth map where we can track how far this point is from the center, because really we don't want to touch anything. We don't want to change anything that is not other than the score. We don't want to erode everything. We want to only erode the edges. Okay, so we can increase the number of pieces at the outer layer and constrain or lock or block the center, or something that says, okay, this area you're not gonna get in no matter what. So we can maintain the core of the geometry. But let me show the idea of the depth mask, or the how far the geometry is from the center. I'm gonna create a sphere, and I'm going to connect this into here, which will create a sphere at the center, centering, basically encompassing the entire geometry. And then I'm going to use an assemble node and convert that into a packed primitive, and then use an add and delete geometry by key points, and this will give me a point at the center of the bounding box of a sphere that encapsulates everything. And from that point, I'm gonna group this point and call it center. And then I'm gonna take all the other points, which are these guys, and I'm gonna call them all. Okay, and let's merge these two. And this is what I will use. I will add that point as well in the Voronoi fracture. Okay, so it gets used in there. And then I'm going to use a Tidra node, and I'm going to set it to connect. Instead of Tidra, I'm going to say connected polylines. And let's turn this off. This is going to give me a connectivity mesh between all the points. It's basically a connection between all the points, really. And what I'm going to do next is I'm going to use find shortest path and tell it to find the shortest path from the center to the all points. And this is going to give me a very, very interesting map. And let me do it so you guys can see it. So find shortest path. I'm going to say the starting point is center. The end point is all. This is the groups that we've set up. I'm going to say from any start to each end. From any start to each end. And this is going to give us a connection between all the pieces. And if we look at the path it takes for this piece to get here is longer than the piece than this one, and is longer than this one, and so on and so forth. And we can use this information, and is provided by this guy, is provided by the node. It's called path cost attribute. Okay, and it's also the cost attribute. I can't remember what's the difference, but we're going to use the cost attribute, sorry. And that tells us how far the object is from the geometry, from the center. And we need a way now to copy this back onto the geometry, onto these guys. But unfortunately, we don't have any way at the moment. So what I'm going to do is I'm going to create an attribute on these points. I'm going to call it origin pt, and it's equal the pt num. And let me check one more thing. And then here we have to make sure that this is the attribute that we want to use to track the points, and that's going to be persistent between this point and this point. And so let's copy attribute copy to the points, and we want to copy the cost attribute, and we want to match by the orig pt. Now if we fracture using this, and we have to make sure that to copy, let's use the new Voronoi so it's consistent. I'm gonna delete this. Let's use the new Voronoi. It's fine with the fuse, it works. And we're going to tell it to copy the points attribute to the geometry. And not this one. Copy cell points attribute. And we want to copy the cost, not this one. We can copy, let's copy it 2 points for now. Okay, and let's use a color. Let's turn this off. And let's look at the cost attribute. You can see it goes between 3 and 0. Let's create a ramp from attribute. And there we go. With this, we can say, okay, these guys, we're never gonna touch. Okay, this core, we're never gonna touch at all. And this way, we will be able to only activate that and maintain something from the sim. This is one way of doing it, and I actually like this information because what we can do with it, even in other scenarios, is we can drive the strength of the glue cluster or the strength or any attribute from the geometry. We can say, okay, these guys, they have weaker fracture, they have weaker glue bonds, and that way, which is the case, these edges are going to hit first. And when they do, they're gonna fracture faster. And as it gets hard, and as it starts revealing more of this piece, it's gonna start facing stronger bonds and so on and so forth. So this mimics the strength of an actual, a real brick or a real concrete block. And that's pretty much it. So we have this information. I'm gonna leave it there, and let's see what else do we have. That's it. That's all we need for now. And let's keep that. Let's keep this as well. And let's do a compiled block. And I'm gonna use the entire geo. Let me turn this off, or now let's use this first to make sure that everything's fine. As long as I don't have any outputs, any extra outputs, this should be a straightforward process. And let's connect this here. It's multi-thread. Turn this off. Yeah, it's definitely much faster than before. Okay, let's wait for a bit. And so the final fracture here is very, very basic, and the simplest way, if we start messing around and trying to do all kinds of crazy fracture on these small pieces, the result is not going to be great. We're going to start seeing a lot of edge and inside faces issues, and the best way is to increase the level of details and use some kind of clustering techniques like the RBD cluster, which will share the names of the pieces, and that will help with creating a more blocky clustering. But so far this is gonna work great. I know this already. Let's see. I don't know what's happening. There's a couple of nodes that are not compilable, so this is not going to work. The find shortest path, yeah, you can see the thing here, so this is not going to work, which is fine. And it shouldn't have done that, but I'm going to run it on the entire geometry. I think that's pretty much it for the fracture, and I'm going to cache the geometry to disk. And we'll continue in the next video. Actually, I'm going to lower this to 50 because I think 100 is a lot. And let's delete this guy. Let's delete this. And let's cache this geometry. Upres main. Okay, let's hit save. Only 220 pieces. Let me check. Oh yeah, I'm gonna remove that. So this is the entire geo. I'm gonna let it run. Yeah, this is more like it. So we'll continue in the next video once this is done, and continue setting up the system to trigger the activation between the pieces. Thank you guys for watching, and see you in a bit.